Hello everyone! So earlier this week, I created a bot for Wordle. And in this video, I will show you how I used OpenCV and Python to visualize the results of the Wordle bot. Okay, so at the end of this video, we will be producing images that look like this that shows you how the bot answered each game of Wordle. And our end result is a GIF that would look like this that compiles all of the images that we produced and shows all of the possible words that were played. Okay, so that is our end result. Okay, so let me show you how I did it. So let's go over to the code. But before that, the Wordle bot, when I ran it against all the possible words, 2,315 words, it produces something like this, a CSV of the results and how it played. Okay, so you have the words here, the number of tries, the duration, the time it took for it to finish the game, and then the game itself. So you will see the guesses here and then the results. So XYXXX means that only the second letter was yellow and then the rest were duds or wrong. And then if you have G's, then that means that it's green. And then it shows you the next guess, and then after that, the final guess, which is the correct answer. Okay, so the bot produces this for all the possible games that it played, because I ran it across all possible 2,315 words. Okay, so this is the output that it produced, basically. So I want to visualize this so that we could have something like this, right? So we will use OpenCV and Python to do that. Okay, so let's build the code from scratch, and I have here the skeleton code. So first, of course, we'll import the necessary modules. So we have CV2 for OpenCV, NumPy, which we'll use for creating blank images or blank matrices, right? And then imageio is a module that I found that creates GIFs. Okay, so we'll use this later at the end when we are creating GIFs. Okay, I've also defined some of the variables that we'll be needing. So word length is equal to 5, because of course there are 5 letters for each Wordle game, right? And then max guess is 6, because you have a maximum of 6 guesses, right? And then so the game width is the word length, and the game height is the max guess. So you have this is one game, so there are 5 letters and then 6 guesses maximum. So that is the height and width of one game. Okay, so we'll use these variables later on, so I'm just setting them up now. Now the square width and the square height is 50 by 50. So each square here for the letters has a 50 pixel by 50 pixel dimension. Okay, now for the number of games across the x-axis, there is 5. So you have 5 games that we can display in one line, and then for each page there are 3 rows. So you have 3 rows basically for one page, right? So num games y is 3. So the number of games in one image should be num games x times num games y, which is 15 in total. Okay, so those are the few variables that we need to set up first. And then the input path that we'll need is, of course, this results.csv. Okay, so this is what we'll read later on. And then the output directory would be in image. So I've already set this up here. So results.csv is here. The image folder right now is empty, and this is where our output images will be saved later on. Okay, so I've set up the function create images with input path and output directory as the parameters. Okay, and I've commented out some of the syntax for the OpenCV and NumPy functions that I'll be using later on, so that I don't forget the proper parameters and yeah, what I need to pass in. Okay, so yeah, so let's start with create images. I've also commented out the steps so that I don't forget what they are. But we will be doing this from scratch basically. Okay, so the first thing that we'll do is we will read the input file to produce a list of games. Okay, so we will have the list of games here. Okay, wait. Okay, games would be a list, right? And then so what we'll do is we'll open the file from the input path, right? So the file is we'll open the input path, and we'll also close it after using. So we'll read each line. So read lines, and then let's see. So it looks like this, right? So this is the example. Okay, so what we're going to do is we'll read it as the data. So line dot will strip the extra white spaces at the end, and we will split it by the comma because this is CSV, right? So we'll split it using comma. And so for now, let's try to print out the data. See how it looks like. Okay, that looks fine. Yeah, so the first four is well, we only need the word here, I think, and the duration probably, if you want to let's say display the duration as well. But for now, let's say that we only want to get this part here. Okay, the gameplay part. Okay, so this is 0, 1, 2, 3, 4. So it's 4 onwards. Okay, so the game, wait, the game is data from 4 onwards. Okay, and we don't know the end because the games differ. Like some of them could be answered in 2 tries or 3 or 4 or 5 or 6, right? So we're not really sure how many guesses we had. So we'll just start from 4 and then onwards up to the end. So if we just print the game now, then we will yeah, just have the guesses itself. Okay, so this is what we'll get. So we will save those in the games na array, games dot append game. Okay, so now that we have read the games, okay, so I'll just get the gameplay. The next step is of course to create the blank image, and then we'll put this in a function because it turns out that we'll be reusing this piece of code because we'll be creating a new image for each page, right? Because of course there's only 15 games that will fit in one image. So for the next 15, we'll have to create a new blank image, right? So for the create blank image, we will use a function for this one. So image is equal to create blank image. Okay, so I'll create a new function, create blank image, and the image would be a numpy zeros matrix, right? So we have to specify the height and the width of the image, right? So what is the height and the width? So we'll call this image height and image width. Okay, and we'll define that here. Okay, so how will we define the image width and height? Okay, so here this is 50 by 50, right? And then there's 5 of them, 5 letters across, plus this margin here is also 50 pixels. So all in all, that would be the width of the game plus 1, right, times the square width 50. And then we will multiply that for however many games we have across one row, which is 5, right? So the image width would be the number of games in X, which is 5, times the square width, which is 50, multiplied with what was that? Game width plus 1. Okay, why did I add plus 1? Because for each game, you have an extra 50 pixels for the margin. Okay, so this 50 here is for the margin, this 50 here is for the margin, and so on, right? Yeah, and then for the height, we'll do more or less the same, but this time the square height times the height of the game, which is 6, right? And then add another 50 for the margin, and then multiply that with the number of games or the number of rows that we have, which is 3. Okay, so that would be num games y, so that's 3 times the square height times the game height plus 1. Okay, so that would be our image width and height. Okay, so I've now computed the image dimensions. This is okay. So going back to creating a blank image, we will return this. Okay, return the image, and let's just print the image height and image width for now. Let's see. So it's 1050 by 1500. So the height is 1050, the width is 1500. Okay, but we actually forgot the margin for this one, the last margin here, because we have a margin for this game is on the left, right? So the last margin on the right is not included yet. Okay, so we'll add this margin and then the margin at the bottom as well. So we'll actually add plus another plus another square width, right? Okay, and then here I'll add another square height, which is 50. Okay, so yeah, that's it for the blank image. And so let's see what we've created so far. So let's draw that image for now. Let me have the CV2 imageio image and weight key 0. Okay, so it's just a black image basically, but we want a white image, right? So we want to add 255 here. So since it's all 0, so it's all black. So if we add 255, it becomes white. So if we display that again, then now it's a white image, right? Okay, so that's okay. But I also want to add the page title to the top center, like this, WordleBot by Roybot, so that the page has a title, right? So okay, so we will do the writing of the text. So we'll call put text here. So for cv2.putText, you have the image already. Now the text would be what was that again? WordleBot by Roybot. Okay, yeah, that's it. That's my Twitter handle, by the way. So that's the text, and then we will need X and Y. Okay, so what would be our X and Y? So for X, maybe at 0, 0. Let's try that for now. For the font, we'll be using this font Hershey plain. So let me define that here. Font Hershey plain. So we'll use this as the font for everything. So I'll just define that up top. And then the scale, maybe scale of 1 for now. Let's try. And then for the color, this will be black. So I'll define black as a variable here at the top also, because I'll be using the black color a lot of times. So black is 000, so that's a triple for black. So yeah, it looks like we're set for now. We have the image, we have the text, we have the starting position, the font is defined, the scale is defined, and then we have the color. So let's see how it looks like. Looks like it's somewhere here at 00. So maybe we need to adjust the Y. Maybe we need to bring it down to about 30. Let's try that. Okay, now it's visible, but this is I think this is too small. So maybe I'll up the scale to 2. Okay, now that's better. It's bigger, but I want this to be at the center, right? So I have to adjust the X value, the starting point. So I won't do it at 0, but maybe at the middle, right? So what is the middle part of this? This would be the half of image width, right? Image W over 2. But if I'm doing division, this becomes a float, so I'll have to typecast it back to int, right? Or convert it back to int. There's no typecasting in Python. So image width divided by 2, that would be the center theoretically. So let's see if that will put it at the center. Not really. Well, it started at the center, but the word itself is offset, no? So what I want to do is put it at the put the word at the center. So what happened here was that, okay, so let's say that this was the center. If this was the center, this is where the text will start, right? So we don't want that, because we want the text to be centered itself. So what I want to do is, instead of doing this, I have to pull the text back by a bit, like going to the left, right? Now how will I do that? Okay, so there is a function in OpenCV called what was it called again? Wait, it's called get text size. Okay, so get text size will compute the number of pixels that this text here will require. And then if you get the size, then I could subtract half of the width of this text, so that I could start the text here and put it at the exact center. Okay, or not the exact center, but put the text centered. Okay, so let's try that. Okay, so let me copy this one. So before putting the text, we have to adjust the X and Y, right? So this would be this get text size would return the first return value is the size. The second one we don't really need, so I just put underscore there. So get text size of the text. Okay, so the font is CV2 Hershey plain, so I'll just use the font variable. The scale is 2. Okay, so let me put scale here. And for the thickness, let's just define this as 1. Okay, so for now, let's try printing the size. Let's see. Okay, so it's 423 by 19. So it would be width is 423, and then 19 is the height. So this is the number of pixels for the text. Okay, so I want to get half of this and subtract it from starting point X, so that this will be offset the position of the text. So what I want to do is okay, so WH is equal to size, and then what I want to do is X would be subtracted by int W over 2. Okay, let's try that. So the width here, 423 divided by 2, and then we'll convert that to int. We'll subtract that from the starting point X to pull the text back. Yeah, let's try that. Okay, now it looks better, right? It looks centered. So yeah, okay, so that's it for creating the blank image. So this is the blank image that will always produce at the start. Okay, so we've now added the page title to the top center. That's okay. Okay, so next is we will try to draw um, one of the guesses, right? So like here, this one. Let's start with the basic one, which is one line of one guess, basically one word. Okay. So games is a list of games, right? So let me just get one game. So maybe games 0. Okay, let's try to print game for now. Let's not show the image first. So yeah, this is the first game. Okay, and this has 3 guesses, right? um, but actually I want this to be split into 2, right? Because I want the word and the result to be separate. So going back here, I would split this x dot split by slash for x in data 4. Okay, so let's try that. Okay, now it has split. Okay, so it now is a tuple or a list with 2 entries. Okay, so the word itself and then the result. Okay, so let me try one guess and result. So let's see, the word itself and the result is the game 0, which is this one, this first one. Okay, or maybe I call this guess index is 0, so the guess index from the game, right? So the guess index here is 0, right? So what I'll do here is, okay, let's try to print the word and result first, if that's correct. So it is raise and xyxx. Okay, so let's go through each letter. So for I and letter in enumerate of word, let's try to figure out what the color is for each letter based on the result. Okay, so this one has 5 letters, this one also has 5 results, so x, y, or g. Okay, so if the result of I is equal to green, G, then the color would be 0 to 550 because that is green, right? RGB. Else, if the result is yellow, then the color should be 0 to 55 because that is the color yellow, right? Green and blue are full, and then 0 for red. Otherwise, if it's X, okay, then the color should be gray, so maybe 150 for all 3 channels. Yeah, okay, so that's the color. So we figured out the box color from the result, so this is okay. And then next is, so I'll indent this one, one box and one letter. Okay, so let's try to draw one box first. Okay, so how will we do that? Okay, so for one box, we'll use the cv2 dot rectangle, right? Okay, so for cv2 dot rectangle, what will happen? Okay, so you have the image, you need the starting point and the end point, so the 2 corners, right? The top left and the bottom right corner, then the color, and then the thickness. Okay, so let's see. Okay, so for x1, and y1. How will we define this? So where will we start our rectangle? Okay, so maybe this game should start at like this is the first one, right? So this should start at about 50-50, right? Because this one has a margin of 50, this one has a margin of 50. So this should start at the point 50-50. Okay, so maybe I'll define that as game x is equal to game y square width and the square height, which is 50-50. Okay, so that's where we'll start for now. So x1 and y1 for now would be game x and game y. Okay, so that's our starting point. Now for x2 and y2, it would just be x1 plus the width of the square, which is xqw, and then y2 would be y1 plus the height of the square, which is 50. Okay, so we now have x1, y1, x2, y2. The color would be here. Well, we've defined the color here, and for the thickness we want it to be filled with that color, so we'll do -1. Okay, because -1 color is for fill. Okay, so let's try that and run it. Well, we commented out the showing of the image. Okay, now why did it only print out one color, one box? That is actually the last one. It's because we're starting at the same starting point, so it's actually overlapping, right? So if we show it here, like at each time, and then wait key, okay, if we stop for each letter, we'll actually see that it changes, right? And then it ended. But since we're starting at the same x1 and y1, then we are overlapping, or we are overwriting the squares. So we want to move the origin of x1, y1 if the letter is let's say already in index 1, index 2, index 3, and so on. So what we'll do is we'll create an x offset, okay, which will be defined by I times square width. And why is that? Because if you are the first, so index I is 0, then you won't have any offset because this is 0 times 50. But if you are the index 1, like the second letter here, then you will start at plus 50. Okay, and then if you are at index 2, plus 100, and then index 3 is plus 150, and so on. So we will add this x offset here. Okay, so let's try that again. Oh, now it's showing. So let's maybe put this back outside of the loop so that we don't have to stop every time. Okay, so now it looks like the squares are shown properly, okay, since we did the offset for x. Now I also want to add a border, so I'll do the same rectangle, but this time the color would be black, and I would define the thickness to be 2 so that it becomes a border like this. Okay, so it's the same rectangle, but we did not do a fill, we did a black border. So yeah, that's the result. Now we also need to add the letter itself, right? So we will have to pull the put text syntax again here. So put text, image is defined, text is defined. Well, the text is not yet defined. The text should be the letter, and I'll probably get the uppercase for this one. And then for the x and y, okay, let me define the x and y for the text. X, y would be at, maybe we'll just use x1 and y1 also. Y is equal to y1. So if we do that, let's see what will happen. Okay, the font is already defined. The scale, let's try 2. 2 also. Make it probably big. And then the color would be black. Right? Okay. Let's try that. Now, okay. So, it looks like it's okay ang size niya. Maybe we want it bigger, but definitely we want to move this down, right? So maybe not at y1, but maybe at y1 plus maybe around 30. Okay, let's see. Okay, it moved down, but I definitely want to make these letters bigger because it doesn't fill the box completely. So maybe I need to up the scale to 3. Okay, that looks better, but we need to bring the letters down a bit. So maybe plus 40. Okay, so that looks fine, but we need to move, I think, the letters to the right a bit. So maybe plus 10. Okay, that's better. So that looks better now. Okay, so that is the first guess, right? And that would be the foundation of everything. Okay, because we will now loop through all of the possible guesses. Okay, so we're done with one box and letter, drawing all of the boxes and the box borders. Okay, so we're done with drawing one guess. Okay, so that's fine. Okay, so let's move that up here. Okay, next is so this is only one guess, right? Oh, sorry. This is only one guess for now, but there are 3 guesses here. So what we'll need to do is, the next step is to draw all the guesses in one game. Okay, so to do that, so we just said that this is guess index 0, right? So maybe we have to loop through all of the games, or all of the guesses, right? So for guess index in range of the length of the game, right? Okay, so let's see if this is the guess index. So we have to remove this now because guess index is defined here, and then we'll have to indent this to put everything inside the loop. For now, let's see. Okay, so if we do that now, then you'll notice that only a back is being printed again because of the overlap thing. So we are starting at the same x and we are starting at the same y. So the first guess is starting here, and then the second guess is also starting here, the third guess is also starting here. So we are actually not moving the guess downwards. So we have to adjust that as well. So for the y1, this is where we will adjust the y offset. Okay, so the y offset would be so what would be the y offset? So this would be the guess index, right? So how or which guess are you? Are you the first guess, the second guess, or the third guess, and so on? So guess index times the square height. Okay, so that if you are the second guess already, you will move down. Okay, and then if you're the third guess, you'll move plus 100. So the first one is plus 50, plus 100, plus 150, and so on. Okay, so we will have to add the y offset here. Okay, with that change, let's see if that fixed everything. Okay, it fixed everything. So now you can see the 3 guesses in each of their lines. Okay, now we also want to add the blank guesses if needed. Okay, so if we have extra guesses, like it's not yet 6 guesses, we have to draw blank what do you call this, blank boxes, just like this. Okay, blank boxes. So we have to change it here. We cannot loop from the range of the length of the game, but we actually have to loop from 0 up to 6, which is the max guess. Okay, so we'll change this to max guess, but we will only do this part here if the guess index is less than the length of the game. Okay, okay, so maybe I'll define length of game as num guess, which should be the length of the game. Okay, so if it's less than the number of guesses still, then we have a valid guess to output. Okay, so we'll use the code that we had earlier. However, if it's after that, then we will have to draw blank boxes. Okay, so for I in range, what's the variable called again? Word length. Okay, so for I from 0 to 5, word length. Okay, we will have to draw boxes. So we'll more or less do the same thing here. Okay, so we'll draw a rectangle also, but this time it won't be filled with a color, it will just be white. So maybe I'll just copy the border code here. So the image at x1 y1 x2 y2 will be we draw a black rectangle with thickness of 2. So the thing that we'll need to define is x1 y1 and x2 y2. So x1 would still be the same. It would be game x plus the x offset, and y1 would still be game y plus the y offset. Okay, and x offset would still be computed the same way. It would still be I times square w. It's the same as this. Then y offset is also the same. Okay, and then for x2 and y2 also the same, because you just need to move the x1 plus 50, y1 plus 50. Okay, and that's it. So let's see. Okay, so it now drew the extra 3 boxes that we needed. Okay, so we have now completed all the guesses in one game, and we also drew the blank guesses if needed. So we'll add that at the top. Okay, so next is we will need to draw now several different pages, or several different games in one page. So drawing one page, let's try it first with the first 15 words, so that we don't have to go to the next page yet. Okay, so for now, let me filter games is equal to games up to 15. And why is it 15? Again, it's because we have 15 games in one page. This is only temporary. This is so we can focus on the first 15 games, right? But of course, later on we will have to do this for all of the games, right? So for now, since we're still building the code for one page, then we'll start with the first 15 games. Okay, so okay, so here we hard coded the game to be games 0. So now we will have to loop through all of the possible games. Okay, so yeah, so okay, now what will happen? So for game in the games, right? And maybe I'll enumerate this so that I can get the game index. So enumerate games. Okay, maybe let's try this for now. We'll stop here, we'll return, and then let's just print the game index and then the game itself. Okay, so those are the possible games from 0 to 15. Okay, so now this would be removed because of course we now have the game itself that's being looped through, and then we will indent everything so that it will be part of the what do you call this, the loop. Okay, so let's try running this now. Okay, the problem here now is the same overlapping problem that we've had earlier. So all 15 of them started here and actually um, drew their game in this area. So to show you that this is indeed overlapping, I'll show you the okay, so that and then that and then that. So it's drawing on the same area. So that's why at the end we only see one part. So we have to adjust now the starting position of the game X and game Y because we've always been starting at 50-50. That's why they are overlapping. So we have to adjust them in such a way that they will be tiled accordingly, like this. Okay, so first we will have to compute some things, right? So like for example, let's see. So we have the game indices here, right? So this is okay. Let me set up my okay. So this one is this one is game game 0, game 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, right? So using those indices, we will have to adjust the position of each one. But we also have to know that each game, like each box here, will have a width and a row, a width and a height. So what is the width of one box? That would be the square width, which is 50 times 5, and then plus the other one here, so 50 times 6 really. Okay, and then here it's 50 times 6 plus 1, so 50 times 7. That would be the height of each box. So that we will use that to offset everything. Okay, so let's try that in the code. Okay, so going back here, let's try to define one box's width and one box's height. So this is actually the square width times number of games, which is the word length, game width, which is word length, and then plus 1. So that's actually this one, right? So this could be replaced by box width. And then similarly, this one is the box height. Okay, so the box height is the square height, which is 50 times the number of guesses, 6 plus 1 for the margin. So that is the height of each box. Okay, so how will we know like which row, given the game index, which row it is? Like this one is row 0, row 1, and row 2. And then for the columns, column 0, column 1, column 2, 3, and column 4, right? So how will we know the box column and box row? So we'll have to compute that based on the game index. Okay, so let's see. Okay, so for the box index, so this is the index of this box, like 0, 1, 2, 3, 4, 5, 14. We will use the game index for now, but later on, when the games are exceeding the 15, like it's already at game 100 or game 121, then we will have to use modulo num games image, so that everything will fit. Okay, so basically, like if you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or okay, let me just run it so that you can see it, right? So we'll continue here so that it will skip the rest, and let's try not to limit it to 15 games. So the box index would be printed alongside the game index. Okay, so that's it. Go back to the top. So the first 15 from 0 to 14 would have the 0 to 14 the box index, and then when you reach 15, it will reset back to the 0 to 14, because this will be another page, and then the 30 to 44 would be another page, and so on. Okay, so we will use modulo numGames image so that it would keep the numbers from 0 to 14. Okay, because there are 15 games in one image, right? So that is the box index. Okay, so if we put it back to games 15, and yeah, okay, so now we need to figure out the row of the box, okay, and the column of the box. Okay, so let's try to print the box index, box row, and box column after that. So what is the row number of each one? Okay, so from 0 to 4, this should be row 0, right? And then from 5 to 9, row 1. From 10 to 14, row 2. So it looks like if I divide the index by 5, the quotient should be the row number, because 0 divided by 5 is 0, up until 4 divided by 5 is also 0, and then with the remainder, right? And then here, if it's 5 divided by 5, it's already 1. 6 divided by 5 is 1, and so on. And then here, it's 10 divided by 5. 14 divided by 5 is still 2 with a remainder. Okay, so we will use box index divided by the num games at x, which is, if you recall, 5, right? And since this is division, we have to convert it to int. Okay, and then for the box column, okay, so how do we get this column numbers? Well, it looks like it's the modulo, the remainder, right? So this one is 5 divided by 5 is 0, remainder 0. 6 divided by 5 is 0, remainder 1, right? So we'll use modulo here. So that this would be box index modulo num games x. Okay, so let's try to print that first to see. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then at 5, 1, 0, 1, 1, 1, 2, and so on. Okay, so we now have the box row and box column. Now, why is this important? It's because we will use that to compute the starting position of each box. So this game would start here at 0, 0. This one would start here. This one would start here, and so on. Okay, so from here, from s square width, which is 50, we will add the offset, which is the box width that we computed here. So this is the box width, right, times the column. Okay, so what column are you in now? And then for game y, the box height times what row are you in now. Okay, so that will offset everything, and with that adjustment, I think we could print everything in one page. So let's see. We're still doing the pause thing. So okay, if we put it back here outside and maybe resize it because it doesn't look like it fits, right, the window size. So let's copy resize just for the showing. So resize to 75%. Okay, now it looks like we have shown everything. Okay, so that looks good, that looks okay. So now we've drawn one page, so we're content with that. Okay, the next thing is now to draw all pages. Okay, so when we finish one page, we need to save it and create another blank image so that the next set of games would be added to the next image, and then we will save it, and then yeah. So okay, so we'll remove this one now. We won't limit it from games, the first 15 games. So everything, all of the games here are now being, what do you call this, considered, right? So when will we know when to save the image? So once we reach 15, so multiples of 15, we will have to save it, right? Because we know that 15 images or 15 games have already been placed in the image. So what we'll do is check if the game index modulo the num games in an image is equal to 0, meaning it's evenly divisible by 15. Okay, the game index. If it is divisible, then we will save it. But we also need to check another one, which is that the game index is actually greater than 0, because 0 modulo 15 is also 0, but we don't need to save it at index 0 because there's nothing to save yet, right? So only if the game index is greater than 0, that's when we will save it. Okay, so we will save the image here. So the saving of image is I am right. Okay, so we need the path. Okay, so for the path, we'll put it in the output directory, output dir plus okay, so we'll need the page number. So page starts at page 1, so I'll name it with a page number with 3 digits. So if it's 1, it's 001, because there's about 100 pages here. Okay, with page. Okay, so let's try that. And of course we will have to increase the page so that it goes to the next page. After that, okay, so maybe page 1 after writing, and then we'll have to reset the image. We'll have to create blank image again. Okay, because we've already saved the previous one, and then now we will have to save it, right? And when we do that, let's try to print the path just so we know that, hey, I have saved this image, right? So it looks like it's okay. And then the last thing is we will also try to save the last page, because this will only you will not save the last page because it will already exit the loop. Okay, so at the end of the loop we will also write it here. Okay, so let's copy these 3 lines and do that one here, and we don't have to show the image anymore because we will be saving all of them now. So yeah, so we've written the image, the last page, and yeah, okay. And then the last thing is to create the GIF, but we'll revisit that later. Let's try to see if this one works first. Okay, so it looks like it's saving some images, but let's see if our images are correct after this. Okay, so if it finished everything, 155, and let's see. Okay, so now it has 155 images, and let's try to open it. And yeah, it looks like we are almost done because all of the words now have been processed and each game has been visualized. Okay, so the last step now is to convert this into a GIF. Okay, and let me just show you the last page. Okay, so this is the last page that we saved, and it's not full because this is already the like the tail end. Okay, this is the last one. Okay, so the last step is to create this into a GIF. So for the GIF, we will have to create the images list of images. Okay, so it's a list, and each time we'll write it, we'll append this image with another read of the path. We'll read it again because the image format of CV2 and image format of imageio is different. So if we use the image that we have now, it will look different for imageio because remember that OpenCV uses BGR color space, whereas imageio follows RGB. So if we flip that, or if we use the CV2 image as part of imageio, then it would be messed up. I think the end result was that the yellow color became aqua, I think, because of the instead of 0255255, it became 2552550, right? So yeah, so let's just add the images here, and then we'll add it here as well. And then for the last part, we'll just save the set of images into results.gif with a duration of 0.5, meaning each image will be shown for 0.5 seconds before moving on to the next. So let's run it again. So it saves all of the images again. And at the last part here, it should be saving the GIF. Okay, so it takes about 9 to 10 seconds for the GIF to be saved. So let's just wait for it a bit. And it should be done right about now. Okay, yeah, it's done now. So let's see. So we now have the results.gif or GIF, however you want to pronounce that. And yeah, so this is the end result of visualizing the WordleBot answers, or the gameplay of the WordleBot. Okay, so that's it, and hopefully you learned something new, and hopefully you were inspired by the process of starting from one line of the guess to expanding it so that the letters don't overlap, and then the guess don't overlap, so you put it below, and then for one game you add like extra boxes below, and then displaying all of the games in one page, and then saving all of the games with different pages. Okay, so that's usually the process when you do OpenCV. You start from the basic one, and then you expand it and you expand it until everything becomes processed. Okay, so hopefully you learned something new, and that's it for now. I will see you next time.